Alright, we're going to be working on Algebra 1 3.2.3. This is the what's identifying functions quiz. Um, as we've been doing, we'll be using the checkup problems that are before the quiz. So this is the 3.2.2 checkup, and then we're just going to roll right through it. Alright, so the first question is the cost for a rental truck C of X. So what that tells us right away is that the expression C of X, C parentheses X, close parentheses, stands for the cost. So that expression C of X represents the cost. And it depends upon the number of days the truck is rented. So the cost is the dependent variable because it's depending upon something else, and what it's depending upon is our independent variable, which is going to be the days the truck is rented, and they are using X to represent that. All right, they give us a table with four X values and then four C of X values, one in days, one in dollars. And the first question is, what does C of 3 mean, or equal 60 mean in terms of the problem? Well, we know that this entire expression right here, that entire thing, C of 3, is cost. All right, so what we're saying is that the cost is equal to $60. All right, so this entire thing represents cost, and so that means the cost is $60. Now, the 3 took the place of the X, because initially we were given this expression, the cost for a rental truck was C of X. So the 3 is now the X. Well, what does X equals 3 mean? That means for 3 days. So if you rent a truck for 3 days, it will cost you $60. That's what it means in terms of the problem. If you rent a truck for 3 days, it will cost you $60. Because the C of 3, which is the cost, and that told us right away that the cost was $60, the 3 took the place of the X, and the X represents days. Now it's asking is, does this table represent a function? Why or why not? Well, if I look at the X values, there's 1, 2, 3, and 4, so there's no X value that's repeated twice. And because there's no X value, there's no number in my domain, right? My domain is my independent variable. My X is my independent variable. There's no repeated number there, then I'm good. It's a function. So as long as there's no repeated numbers in the X, in the domain, in the independent variable, we have a function. So does this table represent a function? Yes, it does, because every independent variable is matched up with exactly one dependent variable. All right, so 1 is matched up with only 25, 2 is only with 45, 3 is only with 60, and 4 is only with 70. Now, what is the domain of C of X? And then what is the range of C of X? Well, the domain is your X value, is your independent variable. So your domain would be 1, 2, 3, and 4. So your domain is your X value is your independent variables. That's what X is. That's what our domain is. Now our range is our Y values. Our range is our dependent variable. Well, that would be the dollars. Remember, the cost was dependent upon, right? So this is the dependent variable. That's my range. So my range would be 25, 45, 60, and 70. Now list one ordered pair that comes from the table of C of X. So I'm actually going to list 4 ordered pairs. All right, so the ordered pairs for this, if I come back over here, is 1 and 25, 2 and 45, 3 and 60, and 4 and 70. And it's just taking the 1 and the 25. They're right next to each other. The X and the Y are right next to each other. So these are ordered pairs. I didn't crisscross or anything. It's directly a straightforward 1 and 25, 2 and 45, 3 and 60, 4 and 70 written in as ordered pairs. That's it. It's as easy as that. It is exactly what we see. All right, now, next question is, does this list of ordered pairs represent a function? All right, so I can look at the ordered pairs this way and I can make my determination here. I can also do Make myself a chart. I have a 4, a 3, a 1. Actually, I'm not even gonna waste time with this. I was gonna kind of go a different way, but I don't think we really need to. Is a function is simply a special type of relation in which every independent variable is matched up with exactly one dependent variable. Or another way to say it is where every x value is matched up with exactly one y value. So if I go through these ordered pairs, I have a 4, a 3, and I'm just looking at the x values. 4, 3, 1, 2, 4. I said 4 twice. So 4 maps to 10 and it maps to 25. So this is not a function. These ordered pairs do not represent a function because one of the independent variables, the 4, is matched up to more than one dependent variable. If it was just matched up to 10, we were fine. If it was just matched up to 25, we were fine. Even if 2 was matched up to 25, that's fine. I don't care. But because the 4, the x value had 2 different y values, that makes it not a function. What is the range of the function represented by these ordered pairs? Remember, range is our dependent variable, and that is represented by our y values in an ordered pair. So my range for this question is going to be 5, 3, 2, and 5, and realistically, we don't need to write 5 twice. So we could just say my range is 5, 3, and 2. Right, I just took the y values. 5, 3, 2, and 5. And that would be my range, right? It's all the y values. All right, now, does the graph represent a function? Okay, so I'm going to try to sketch a graph over here because I can't write on this, I don't think. Nope. And then I'll take this, and I will. All right, cool. I was hoping they would show it. They don't. Oh, well. Okay, so this is kind of what it looks like. Obviously, it's not a great sketch. What I'm going to do is I'm going to take this and I'm going to draw vertical lines. If you notice, if I go back to showing the answers, it says, yes, this graph represents a function because it passes the vertical line test. There is no vertical line that intersects the graph at more than one place. Well, what are they talking about? Well, the vertical line test is I'm just going to take my pencil and I'm going to draw vertical lines throughout this graph. And as I draw these vertical lines, each one only touched the graph once. So because no matter where I draw a vertical line, no matter where I draw it, it would only touch the graph one time, that makes it a function. That's what it means to pass the vertical line test. Is if you draw a bunch of vertical lines and it only touches the graph once at all of them, it's a function. Now this next example. Does this graph represent a function? Why or why not? I'm going to do the same thing. I'm going to draw a bunch of vertical lines. And as I draw all these vertical lines, each time the vertical lines only touch the graph once. And because it only touches the graph once, it passes the vertical line test, and that means it is a function. All right, now we have one more example. All right, so I draw a parabola. Now I'm going to take my blue line. I'm going to start drawing a bunch of vertical lines. And, oh, I'm done. I'm not drawing anymore. This blue line crossed the graph here and there. It crossed it twice. So this did not pass the vertical line test because this vertical line touched the graph at more than one location. And because it touched that more than one location, that means it fails the vertical line test and is not a function. All right, and I guess I'll do one more example. Here's another example of one that will fail the vertical line test. Oh, that didn't work out. A circle, or I guess now it's more kind of a ellipse maybe. But I draw a vertical line. It crosses. It hits the graph more than once. It is not a function. All right, so a vertical line test, we just draw a bunch of vertical lines on the graph. If it touches the graph only once, is a function. If it ever touches the graph more than once, even if there's only one line that does it, it's not a function.